It will be about the research at NAVER Labs and at NAVER Labs Europe. And I call this part Making New Connections, or AI for the Physical World at NAVER Labs Europe. So we'll start with briefly introducing NAVER and NAVER Labs and the technologies we are building. And then I will spend, of course, some time on introducing some selected research topics at NAVER Labs Europe. Let's start with NAVER. For those of you who have never heard about NAVER, no problem. It is Korea's #1 internet platform. It's a gigantic company in Korea where millions of users every day use their platform to browse the web, look for information, shopping, messaging, navigation, and entertainment in general. NAVER Labs is NAVER's research branch, which is dedicated to shaping the future of NAVER. And in particular, NAVER Labs is preparing the future for NAVER in robotics. What you see here is the new headquarters building. It's called 1784. I will present more about it a bit later. It's Korea's first robot-friendly building. So that's why you will not be surprised when I tell you that NAVER Labs' mission and vision is creating new connections by advancing technology. And this technology is robotics. And the following video will give you a bit of an idea about what I'm talking about. So let's now have a closer look to some of these technologies you have just seen in this highlights video. And I would like to start with 1784, which is Korea's first robot-friendly building. And this video shows you a bit how it looks like there. We have a fleet of around 100 robots that operate in this building on a daily basis, and they fulfill tasks like delivery, like coffee delivery, parcel delivery, or food delivery. So people working in this building, they can use the NAVER app and order a coffee, order a lunchbox, or even get their e-commerce parcels directly delivered to their desk. And this works with, of course, like these advanced robots, but also, very importantly, there is a central control system that we call ArcBrain. This is basically the entire building is connected to this system, and a high-speed communication such as Wi-Fi, but also 5G are used to connect all these robots with the infrastructure of the building, and that's how this works. The next technology I would like to show you is a digital twin. So here we created a system, a technology that allows the creation of a highly accurate 3D reconstructions of entire cities. This can be used for, like, it's the basis for smart cities, for next generation urban planning. And these maps even enable autonomous driving. And the way how it's done is actually we collect all the data from planes, from cars, from human carried devices, and then with advanced AI methods we can create these very nice and very accurate 3D reconstructions of entire cities. And now I would like to move to a third selected technology, which is the newest family member, let's say it like this. It's a new hyperscale data center that is called GAK Sejong. It was opened just a couple of days ago, and it's Korea's largest data center. It's a very high-tech campus, so actually there are also obviously robots in it, and in this case the robots collaborate directly with the human workers, and we have an autonomous shuttle there that drives around people that work there. Also, it's quite eco-friendly because it's powered by renewable energy. And here is again a video that gives you a bit an impression how this looks. This is ALT, which is our autonomous driving shuttle. I haven't been there myself, but I will be there next week, so I'm very excited about it. And here you see a couple of robots. So, for example, we have this robot that is able to remove and to put back servers from the racks in the warehouse. Then we have this heavy-duty robot that can carry, I think, up to 400 kilos of servers between and equipment between the warehouse and the data center. And then we have our autonomous shuttle. So now let me move on to our research we do here at NAVER LABS Europe. And for all people who are joining us today on the stream, so we are here in Grenoble in the French Alps, and NAVER LABS Europe is an AI research center. In fact, it is the largest industrial AI research center in France. And as we are part of NAVER LABS, we are also seeing ourselves having the role of preparing NAVER's future, in particular in robotics. That's why our mission is useful robots in everyday life. And we want, with our AI research, we want to go one step further. Like, we want to bring robots also out of robot-friendly environments. We do that with our about 100 scientists. That includes Ph.D. students and interns that come from about 27 different countries. And we conduct our research in 3 main directions, which is vision, action, and interaction. Across these groups, we have established a common theme, and this theme is foundation models for the physical world. And I would like to take I would like to use this theme and introduce to you 3 selected topics, one for each group. And I would like to start with our foundation model on 3D vision. So building a foundation model in 3D vision was inspired by foundation models in 2D, actually. As 3D is very important for us because we work with robotics, we thought, can we build a foundation model that understands the world not only in 2D but also in 3D? Like, it should be a broad model learned from diverse data sources, and it should be able to understand 3D so that downstream tasks such as 3D reconstruction, semantics, but also camera pose estimation can be realized easily. And we have done that. So the name of our model is CROCO. It has been presented at NeurIPS last year. And the way how we make CROCO understand the world in 3D is like this. So we feed it with millions of pairs, of image pairs that show the same scene, the same environment from 2 different viewpoints. And very much inspired from mask autoencoders, we leave one image as is, and we mask out the large parts of the second image. And then we ask CROCO to reconstruct this, as you can see here. And if you think about this a bit, you will realize that this is only possible if CROCO understands 3D. So once we have taught CROCO to understand 3D, we can now fine-tune it or adapt it to certain downstream tasks. And I would like to show you some of them. Let's start with some low-level tasks. In particular, I would like to talk about stereo matching and optical flow. You know, in stereo matching, it's about reconstructing a scene in 3D from image pairs, and optical flow is about estimating the pixel-wise displacement of consecutive images in video frames. And usually, state-of-the-art methods in these tasks, they use task-specific optimizations, and thanks to CROCO, we don't need that. So we use the large-scale pre-trained CROCO to achieve state-of-the-art results without any task-specific optimizations, such as cost volumes. And we show that large-scale pre-training can actually be successfully applied for dense geometric tasks, which we think is very important, an important step towards having universal vision models. The second task, downstream task I want to show you is more high level. It's about visual localization. In particular, visual localization with scene coordinate regression. So in visual localization, you would like to estimate the pose of a camera using its images. And in scene coordinate regression, that's one way of doing it. There are many others. But in scene coordinate regression, the goal is to estimate a 3D coordinate for each pixel of the query image, meaning of the image you want to localize. And current approaches of this, they learn a scene-specific representation that allows to regress these 3D points. And what we can do with COCO, actually, we can learn a scene-agnostic model that can compute these 3D points. And yeah, again, we achieve quite good state-of-the-art results on several classic benchmarks. And I would like, yeah, here you see some results. On the left, you see the query image, and on the right, you see the 3D reconstruction. As we estimate a 3D coordinate for each of these pixels, we can just show it in 3D. The white areas are areas we could mask out because we also estimate the confidence for each coordinate. And then if you merge all these reconstructions, then you get a bit more a larger complete model. And yeah, it shows that the quality is quite good. Here you see the model is created with the Aachen day-night dataset. The last downstream task for COCO I would like to show you is robot navigation. So here in particular, it's about image goal. In image goal, the idea is to show a robot the goal that is visible in an image, and then you have to learn a policy that for each observation can understand where can the robot actually navigate, where can it exit the current room, and is it already close to its goal. And we do that by, again, using, actually here we use two pretext tasks. First we have COCO, and then we fine-tune it for relative pose estimation, and this is fed into this policy, and after having analyzed each observation, it tells the robot where to go, left, right, straight, turn, and so on, giving navigation commands. Here in this video, you will see a bit how it works. It's in a simulated environment. The blue dot is the robot that is moving. The red dot is the goal, and the red circle shows the threshold when we count the goal as reached. And you see it works quite well. So let's move on to the second part, which is research done mainly in the action group, and in particular it's about foundation models for neural combinatorial optimization. Similar like in computer vision, in 3D vision, as we have just seen, we want to develop a foundation model that is able to solve various combinatorial optimization problems all at once. And why is this important? So first of all, it's a very interesting research question, but also, as you have seen with all these buildings and data centers where robots operate by themselves or in collaboration with humans, tasks such as multi-agent path finding or multi-agent task assignment have to be solved every day. And what have these problems in common? So like the other problems in the first slide, they are NP hard. They have many constraints, many requirements, and they're quite complex. Like this is all complex structures where these robots operate, and they need to be solved many times with only slightly different parameters. And generally, this is done with heuristics designed by human experts. And the objective of our research here is to learn specialized heuristics directly from data, so that we can reduce the dependency on human experts and make everything easier and more efficient. So the first step towards this goal, this vision, is BQNCO. This is a work that will be presented at NeurIPS this year, and it introduces an efficient way to create Markov decision processes that exploit symmetries of combinatorial optimization problems that are of recursive nature. And what we show is actually a flexible transformer-based model that allow to learn an efficient and generalizable policy, and with this we can achieve state-of-the-art results on at least 5 classic problems. What we mean with generalizable is we train the model on a small instance of a problem, and then it generalizes to much larger ones. But still, this means that we have to train one model per problem. So inspired by vision and language, we ask ourselves the question, is it possible to train a single model that can be specialized to many combinatorial optimization downstream tasks? And we say yes. So that brings me to GOAL, which is our foundation model on neural combinatorial optimization. And here, starting from PQNCO, the method you saw before, as a common backbone plus problem-specific adapters, we propose a multitask pre-training approach using classic CO problems to learn a generic model that can be fine-tuned to new problems, such as the ones I mentioned before, multi-agent path finding or multi-agent task planning. And this is the first model that shows very good cross-task generalization and can even be transferred to new problems. So finally, I would like to show you something from the interaction group, and here it's about a toolkit that allows users to control foundation models. And this is called DISCO, and it's about aligning sequential decision models. As we talk about aligning, I would like to mention the alignment problem, and I would like to use large language models as example for this. So large language models, they are becoming ubiquitous thanks to their strong generalization capabilities. However, we have the problem that sometimes the text that is generated is probably biased, it's probably toxic, it's probably incoherent, or sometimes it's even completely hallucinated. So the goal of this work is to develop a theoretical framework and the corresponding toolbox to hand over control about such models to the user. So we can have our initial model plus human-defined constraints, and with DISCO and our framework, we can create an aligned sequential decision model, or in this case, language model. How do we do that a bit more in detail? So the framework I'm talking about is called Generation Under Distributional Control. And as I said before, the toolbox is called DISCO. And it's basically a 3-step approach. So first, you specify, as a user, you specify the features you want to control. And then DISCO can help you creating an energy-based model that reflects these features and requirements. An example could be like you want that all answers you ask the model about tennis are gender balanced, for example. This you could do. And then the problem is with this energy-based model, you cannot sample them in an auto-regressive way. So if that's a problem for you, then you can move to step 2. And here you can tune a regular language model in an auto-regressive form that approximates the distribution in your energy-based model. And then sampling is straightforward. So all this you can do with DISCO. We have interfaces to a large variety of standard open source models, and but you can also write your own wrapper to your own model or your favorite model. So that brings me to the end. All the work I showed you and much more, papers, code, data sets, you can find on our website. Many people, like actually everybody who was involved in building this work I just showed you is here these 2 days as well, so we can have many more discussions. And that's all from me. Thanks a lot for your attention, and I wish all of you and all of us a very nice, fun, fruitful workshop. Thanks.